really can't do anything with it that way. So this becomes f of x is equal to x to the 1/2 power. Okay, maybe you don't remember that, but since square roots are the most common, we don't bother writing what the root is, okay? But there's an implied 2 there, and this is x to the first. So whenever you write it with the rational exponent, just remember, roots are in the bottoms of plants, okay? This is your root, it's going to be in the bottom of the fraction. Okay, we'll do a few of these. You'll see, it's pretty easy. Okay, so when we take the first derivative, it's still going to follow the same power rule. 1/2 times 1 is 1/2. Then x to the 1/2 minus 1. Fractions, nobody likes fractions, right? Well, that's the same thing as 1/2 x to the 1/2 minus 2/2, if you get a common denominator. So it gives us 1/2 x, 1/2 minus 2/2 is negative 1/2. Which, you know how in algebra you're not supposed to leave a negative exponent? Well, once you get to calculus, nobody really cares. So I'm just saying. Because we have bigger fish to fry. Okay, so you can leave a negative exponent, it's fine. The easiest thing to do, though, is just subtract these two. Okay, 1 minus 2 is negative 1. That's the new numerator. The denominator is going to stay the same. I'll show you what I mean. I'm getting a really bad headache. Wow. Okay. Okay. So suppose my function is the cubed root of x. Okay, so I would first rewrite it. So you have f of x is equal to x to the 1/3 power. Okay, the root goes in the bottom of the plant. Okay, so now when I take the derivative, 1/3 times 1 is just 1/3. Then just subtract those two digits. So 1 minus 3 is negative 2, so this will be negative 2/3. This is a little shortcut thing. Okay, so what about if I have the 4th root of x to the 3rd? Okay, if I rewrite this, it's going to be f of x is equal to x to the 3/4 power. Okay, exponent on the top, root on the bottom. Okay, then the derivative part's the easy part. So 3/4 times 1 is 3/4. Subtract these two. 3 minus 4 is negative 1, so it's going to be negative 1/4. But you can tell, okay, if you have 75 cents and you subtract $1, you're down 25 cents. I don't know, money's always easier to understand. So that is not so bad, right? Okay. Now, hopefully you also remember this. A negative exponent can be made into a positive exponent by just moving. Okay, so if you have, this is just an algebra little thing, okay? So x to the negative 3, that's the same as 1 over x to the 3rd. Okay, 1 over, say, x to the negative 4th, that's the same thing as x to the positive 4. So whenever you move, okay, from a denominator to a numerator or a whole number, the sign of the exponent changes. So when you go from a whole number or like a numerator, you bring it down to the bottom, the sign of the exponent changes. Not the sign of the base, just the sign of the exponent. So if you have a function, okay, so suppose I have a function, it is, say 1 over x to the 7th. Okay. This doesn't look like that. I need this to be in this kind of pattern. I mean, a could equal 1, that's fine. N could be whatever number. But I don't, notice this isn't a fraction. So if I want to follow this power rule that's nice and simple, I need to rewrite this as well. So we're going to rewrite anything in a radical, and we're going to rewrite stuff that has a variable in the denominator. So all I'm going to do is bring this x to the 7th up. And when I do that, it's going to change the sign of the exponent. Hopefully you remember that from algebra. Okay, so now this follows that pattern, where the a is a 1, x is x, and negative 7 is the n. So I can just follow that. Okay, so negative 7 times 1 is negative 7. Now be careful, okay, because we're going to subtract 1. So negative 7 minus 1 is negative 8. And you can leave it just like that. If you had some kind of, I don't know, anal professor, they'd be like this. They would make you move whatever had the negative exponent so that it's a positive exponent. I don't think they need to do that. It's too much work. Okay, so suppose we have f of x is equal to 4 over x to the 11th power. I'm going to rewrite this before I take the derivative, and I'm going to bring this x to the 11th up. So 4x to the negative 11. Now I can just follow my power rule. F prime of x, negative 11 times 4 is negative 44. And then a negative 11 minus 1 is negative 12. That's fine. Not too hard, right? I don't know. I think these are pretty easy. This is just one of several different methods for finding the first derivative. Now, if I have a function that has several terms, okay, and they're not, the variable terms aren't being multiplied by each other or divided or anything weird. Like suppose I have, say, 3x squared minus 5x plus 9. Okay? See how each of these individual terms, there's nothing weird going on, so I can just take the derivative of each one separately. So 2 times 3 is 6. 2 minus 1 is 1. Remember, whenever I just have an x to the first, it's 1 times negative 5 is negative 5, then it would be x to the 0, so the x is gone. The derivative of a constant is 0. Okay, because remember, this would be like x to the 0 power. I wouldn't bother writing. When I bring the 0 times the 9, the whole thing goes away. Okay, so that's not too bad. Let's do another symbol. Of 8x to the 5th plus 3x to the 4th minus x to the 3rd plus 5x squared minus 2x plus 4. Okay, so just going to take the derivative of each one of those. So this guy, 5 times 8 is 40, so that's 40, and 5 minus 1 is 4. Then we do this one, 4 times 3 is 12, and we subtract 1. Like always, be careful with your negative signs. This is going to be minus 3x squared. Then plus 10x. These ones, you'll eventually get used to it, okay, you'll get the hang of it. This one is just going to be negative 2, and the derivative of a constant is 0, so that's just gone. Okay. Okay, so that should be enough to get you going on the power rule. I'll give you some practice problems for that. And I'm going to put your quiz on finding, the limits of functions. And I'll put your grades on. I think everybody's turned their stuff in. Okay, so I'll do some more this afternoon, and there'll be more stuff. I hope everybody's staying well. Oh, just so you know, I don't know anything that you guys don't know about fall semester. I opted to teach in person. Okay, some professors, no. And, like some of them, they're taking care of the 92-year-old mother, or some of them have children that have a lot of health issues. Like if we had a child with cystic fibrosis, I wouldn't leave the house. But anyway, I don't have any of those issues. So I opted to teach in person. So theoretically, the people that are teaching in person, it's going to be live streamed for those who don't want to come to class or aren't coming to class or whatever. And then it'll also be recorded for people that can't watch it at the same time that class is. I forget what the point of that is. Anyway, so, love you. Bye.